So Joel might be chairing this.
Oh, that's unfortunate. How about, do we have Tom here?
We haven't heard from him.
Well, that's unfortunate.
Should we send him an email?
Yeah. Yeah, I can do that. I'll send it to Joel too.
We should start as well.
All right, I sent them an email. And I guess we should start. All right, so I can just use the clicker. Okay. Good morning. Destination check. This is the 6-man working group. Sure you're all in the right place. So this is our second session for Prague. We have some, well, here's the note well. Should ask you to recite it. Ministrivia, and thank you, Mikkel, for jabber scribing. This is the agenda. Well, I can see it here. So the first section is a follow-up on SRH. We hope to get to closure on the open issues. There's been a lot of work during the week. And I think, well, we'll see how the discussion goes, but I think we're close. Well, I guess we have another slide on that. Then there's two active drafts, the Universal RA and the Hop by Hop MTU draft. And then there's a set of new drafts. And we also had things that we didn't have time in the agenda for. But I also want to call your attention to the OAM, the last two drafts. I hope we will have time, but there's the chairs of the IPPBM group would like to make sure we get a chance to look and comment on these. So the plan for the segment routing was to get closure during the week. There's been a lot of, there's been discussion on the email, there's been side meetings. We met with Darren yesterday morning to go through the issue tracker, and several things got closed. I think there's still 8 open things that we're hopefully going to get closed today. And then our intention is to close the current working group last call, and since so there will need to be a new revision of the document posted, and when that's, assuming we get agreement today, we will then do a new 2-week working group last call on the new document, because there's been a lot of changes and it's been a long time since we started, and people should review the whole document. But at least speaking for Ole and myself, we would really like to get this done in 6-man, so then it can go to the ISG and they can have lots of fun discussions too. So. Any comments or questions on the agenda? Okay, good. Okay, Darren.
The clicker. Things are in.
So Bob's all about sharing the joy today. Good. All right. Oh, there's the screen. So SR header revision 17, like Bob had said, we've gone through a lot of work, a lot of late nights, a lot of discussions, a lot of very significant effort by a good number of people. So thanks everyone for your input. It's been really fantastic. I want to remind you of the collaboration. This isn't the kind of only collaboration that's happened. This draft's been out for several years now, 5 years since first implementation. I think now our emails are at 1,500, so maybe more than one line per text, per line of text, so one email per line of text. So thanks this week for that. We're now at 17 presentations, this one included. All right, so the collaboration started for this this particular revision of the draft on Tuesday morning. I met a good number of folks and really listened to what the underlying issues were besides just what was kind of in the ticket text, because that's not necessarily what people are most concerned with. We got a clear definition of what closure looked like for most of them, and then followed up with some prompt resolution on the list, and that continued as we started to kind of work through the items all week and learn more and get the text out. And then on Thursday, we did a tracking update with the chairs. Thanks, guys. That was much appreciated, where we were able to go through and close a whole bunch of more items. And the items that we closed during the week were some tag-related stuff, where we sent out some diffs. Those were accepted. The SRH TLVs, we sent out some diff for those on issue 38. Those were good. HMAC was verified covers the destination, or revision 17 was acknowledged. We had a minor one for moving network programming was acknowledged. Some security-related items around edge filtering got acknowledged as well, and those were closed by Thursday. Now, where we stand today, this is in numerical order so that the chairs can go through numerically and keep track. The first item, number 54, is around TLV limits and alignment of TLVs in the segment routing header. The concern there was that while there are limits in the text saying don't exceed the length of the extension header, there was a request for more limits, basically based on what an implementation could configure to limit the number of TLVs that are processed. And we added text or diffs and sent them out to the list indicating that an implementation can limit the number of TLVs that they processed. On the alignment side of things, there was alignment text in the draft, but there was a feeling from some of the working group members that that alignment text should be in line with what's done in RFC 8200, and that's the NX plus Y or XN plus Y definition of alignment. So we reverted to or modified the draft and sent out diffs to use the XN plus Y type of alignment definition or alignment requirements, and then allow the source node to align the TLVs as necessary in order to meet that requirement of each TLV type. And that was sent out yesterday. Let's see, padding 1 byte. Oh yeah, this was closed a long time ago. Issue number 55, that's actually an old one. We need, well, we don't need to do anything for that. It was closed quite a while ago. We added the pad, single byte pad. There was some must language and should must and SRH appear once that were also closed long ago. So I consider those ones closed now. We had various minor issues from Adrian, don't know if he's here. We confirmed the ones that were previously existing are closed, but then there's a whole bunch of new nits that were brought up. These are all primarily editorial in nature, and diffs were provided with them, so we don't see anything more that needs to be done there. Follow the diffs. 67 on padding and HMAC and flags. This was a question of is the support or is an implementation required to support TLVs and HMAC? And the answer from the working group has consistently been no, an implementation is not required to support TLVs and HMAC. That I responded to in association with this question as well. So that one I think the working groups responded to pretty well, saying it's closed. For 69, adding and deleting TLVs, no, there's no text in here that talks about adding and deleting TLVs. So that idea is closed. The next one was for the SR header, should have some discussion around AH, and diffs were sent out for that, saying that the SR header, for the purpose of computing an AHICV, is mutable, which means the SR header can change. So what AH does is it will zero out the portions of the SR header for the computation of the AHICV. And were there diffs for that? Yes, the diffs were sent out to the list on that as well. Number 7, a local policy is not defined. just trying to, oh yes, okay. Local policy is not defined. So the term local policy, some folks had an issue with saying, well, we don't really know what this local policy is. Describe it. And in discussion, it actually came down to, well, what you're really saying is local configuration. And we'd be happy to say local configuration we'd be happy to say local configuration. Your mic's on, guys. We'd be happy to say local configuration limits, or not limits, but local configuration can specify the things that local policy was previously set up for in the draft. So we've changed the word from local policy to local configuration and expect that is going to close this item. Now, with that, that's the remainder of the items closed. The diffs are on the list. Now the question is, do we close the last call?
Yeah, and I think from the chair's perspective, we'll certainly say, thanks a lot to the authors and the reviewers for having spent a lot of time this week to getting everything resolved. Well, feel free not to come up on the mic. As we started with, our plan is to, with all these issues closed, consider the working group last call, well, this revision of it done. We'll reissue a working group last call with a time limit just to ensure that people get a chance to review all of these changes. And that's dependent on revision 18. Do you think you will have that out soon?
Yeah, very soon. I'm gonna sleep on it before I release it. So, so I'm thinking early next week, Monday, Tuesday.
Yeah.
Yeah.
As if anyone has a burning issue about this draft, please come up now or forever keep your silence.
Except, of course, on the mailing list.
Yeah, we need to pump up that number on the mailing list. 1,500 isn't enough.
Well, cool. I think we're done then for now. That's
For now, yeah. Way to go.
Yeah, thank you.
All right, thank you, everybody. Thanks, chairs.
Thank you. It's me.
Oh, you're next.
So I'm next. Oh. Right, so for a completely different topic, the universal RA option, which does require a bit of suspense of disbelief, just like when you read a science fiction book, to accept the realities behind it. So this is a draft I posted a few months ago in response to some issues that we've seen, which is twofold. I don't go more into that. But it's basically this view that, which is a reflection of the IETF failing getting successfully deployed service discovery, in my view. So it ends up with, we need these general carriers, DHCP being one, RA being another, from signaling information or carrying any information from the network to hosts. And so the idea was, can we make this more generic? Can we make it in a way where you don't need to change the router implementations to add new information objects? And likewise, you don't need to change the sort of core RA processing engine on the hosts. And you don't need to disturb the working group every time you want to add a new object. So the proposal is make a universal RA format. We'll request number 42 from the IANA. We'll see if we can get that. It's a CDDL, concise data description language described object encoded in CBOR. And the point is essentially to do this. So you can, on the network side, you describe your objects as JSON objects. We can argue about the exact formatting of this, or currently everything is text strings, so they can be represented in JSON. You could make a more efficient with binary encoding, but then it's harder to represent in JSON. And likewise, on the host side, a user application interested in one of these objects would just subscribe to a key, NAT64, for example, and it will get notification from the array processing engine when it receives objects for that key. So that would, not require implementation changes in either routers when you add new ones, which have been one of the problems we had. And likewise, if you did the array processing in a kernel or even in a separate process. Here's a typical CDDL representation. So this is an experiment that is twofold. One of them is to, how far can we get away with not requiring an IETF specification for these? So the idea is to put most of the description and most of what you need into an IANA registry. So it would just be the CDDL with either a reference to a external document, a stable reference, or it would just have the description in the IANA registry itself. So as you see, this is a fairly neat way of describing array options. So the problem I'm trying to solve, and as remember that first slide though, is we're spending an inordinate amount of time arguing about these configuration objects, if they should be allowed to go into arrays. Half the people says, well, I don't need it, so I'm not going to support standardizing it. And it takes an awful long time to get it standardized, and it takes an awful long time to get it in implementations. And it's questionable how much value we as a working group add to this process. So the suggestion is, a new IANA registry, CDDL described objects, which is, again, self-contained into the IANA registry, or a stable reference, and just expert review. So if you needed the Pref64 option, for example, you will just fill out the form, get that into IANA, or get through expert review, and it would get into the IANA registry, and you could implement it if you wanted it or not, without any discussion in the working group. So the experiment is along two axes. It's a technical one. What's the advantages of doing a self-describing format, on the implementations, and the cost of doing implementations and the time it takes to deploy things. And it's the process part. What's the consequences of the working group stepping back and letting go, and not involving, these, quality checks that hopefully the working group applies to these. Which means, take the example of the array-only flag, for example, which we discussed for a long time, right, with lots of emails. In this case, someone would just say, well, I defined one. Use it if you want to. You could, of course, still discuss it, but it would still be there and available, right? So there are certainly interesting consequences. There has been, I think the third email, not to point at anyone, but I think the third email was gee, I could use this mechanism if I allowed it in other, in the RS messages as well. I could build new protocols this way, right? And yes, you can, but that's hopefully not something that would pass expert review. So for the experiment, the proposed time is 2 years, finger in the air. It would take us about that much time to gather information. We would get an official code point, so it doesn't conflict with other experiments. And what are the success parameters? I don't know. I mean, absolutely no use of it would possibly be a success. Massive use of it would, well, I don't know if it would be a success, but it certainly would be very hard to shut down the experiment at that point. So to that is, well, you could close the registry, of course, but if lots of people use it, it's very hard to put that cat back into the bag. So yes, so this is an individual draft. The discussion I was looking forward to, especially around the process track. It seems like we can quite quickly agree on sort of the technical modeling language and coding of this thing has been discussed. That has mostly been discussed on the list, not so much, the sort of working group implications and the process implications of this. So yes, please go. Or not. Jen.
Hi, Jen Nicola. I definitely like the idea of speeding up deploying of new options, right? Because it means I can get the support much faster on the router sides, for example, on the host side. But I'm a bit concerned. So this would simplify describing the option, right? So it will be much faster. However, how do you think we are going to define the host behavior in this case? Because I do not think that are we spending too much time discussing bits and bytes and the options. I think the most discussions are normally happening around what hosts are supposed to do. And in this case, it's basically unspecified, right? So I would be very concerned about how can I deploy something if I don't know what hosts are supposed to do.
So there's nothing here that prohibits you from writing an IETF document that describes that, right? And there might be another one that you could reference already that uses this object or a very similar one, right? I mean, the DNS, the RA, well, perhaps that's not a good idea. Let me see if or good example.
So basically, IPv6 only flag, right?
Right.
I don't know, maybe I was missing something, but I think the most discussion was around host behavior. So one flag, like few bits in the option is not really a subject for discussion. So I do not think would have helped much, right? Or maybe I'm wrong here.
Well, for that particular one, I'm not sure the working group document helps either, right? Because it basically ended up saying, well, it's really up to the implementation and what the implementer think makes sense for that. So I would be happy for that one with a single line of text which says, signal sits on a v6 only link, but that's my very pragmatic view. Sorry,
Right.
Eric.
Jen, Eric Klein. The text in the document says if you don't understand an option, you ignore it. So there's that bit of host behavior. But if you define an option, then yeah, and you want people to use it, then you should definitely have a document to say what to do with the option. But otherwise, it'll be ignored. As Uwe said, you should just write a doc.
No, so basically what I'm saying, I fully support the idea of introducing new options in this format, but I think it should not be implemented until we describe what host is expected to do, because I'm not talking about hosts do not understanding the option. I'm talking about hosts doing completely different, unpredictable stuff when they receive that option. I don't know what to expect.
Please.
Hi, Tommy Pauly. So speaking as one of the PVD authors, because you'd mentioned on the list, hey, use this for PVD. So in general, I think this is actually a really, really good mechanism. I would like to see this used for a lot of the basic option pass through, especially if all you really need is the host to just pass it up to some other layer so they can interpret it. Seems really good. I think in the case of PVD specifically, I think that is a little bit more complex of a case because it's specifically meant to be containers of other options. It has a large impact on the host behavior when they have to manage multiple different RAs that they're getting and how those interact with the device. However, I imagine one of the things that we'll want to do in the future with PVDs is because they have containerized options, have more options to extend behavior there. And those should all be this, definitely. So I think they complement each other well. I don't think switching PVD to one of these is the right thing to do, but I think this is very important work still.
I certainly wouldn't, expect PVDs to not have a stable reference to describe how they're used, right?
Right. I just wanted to add, Michael Abramson, to what Tommy said. One of the use cases for PVDs is for legacy hosts to not understand something. So this would mean we would have to have standards for all the normal things that go into an RA to be in here as well, if you want to apply this to the PVD case.
Right. So the current sort of...
So if I want to send a PIO to a PVD aware host that legacy hosts are not going to use, I need to have PIO here in the new format. Yeah,
that's already here. That's
right. Okay.
6 lines of text with a
Okay,
reference.
so we're taking everything that we already have, all the options, and we're putting it here as well.
So, well, that's the experiment, right? There's no, you can put whatever you like. I mean, as long as it's within 2,000 bytes.
Eric Klein. I realize now we also need an R flag. I think it's like 6275 or something. The DNM guys
Yeah.
picked another flag out of the PIO. Yeah, but all of it isn't that onerous, right? I support. I liked the extensibility of this, right? Adding the MTU to the RIO was a nice and easy thing to do. So I do think that if this is popular and successful, certain things we may, like now is the time to take care to minimize the size of things, right? Text strings for prefixes, they can be shorter than their binary representations, but they also definitely cannot be.
Right. I mean, the reason for that is it's very neat to have an API on the router side where the only thing you need to put in is a JSON object. And if we require binary encoding, at least
but you already have something that takes, in theory, can take something from a radius server or diameter server and put it into a DHCP option, right?
Right.
So it'd be similar to that.
You need a little bit more parsing, right? So at least you need, it would be nice to not require implementation changes. But yeah, sure, we can say, with the V6 working group, at least we can do the V6 addresses in binary encoding and require support for that on the routers. But
Yeah.
now the implementation on the router side is 15 lines of code, right? It would be a little bit more.
Thank you.
David Lamparter. So I'm very much in favor of this, and I think we should keep in the back of our heads that having something in here doesn't preclude us from noticing that it's getting widely adopted and hopefully reacting quickly and actually moving it out of this. So I don't think we would necessarily be nailed down to keeping something in this universal option, and I think it's the ideal environment to figure out if something is actually getting adopted, and if that happens, then decide whether we want to keep it in here or create a new option code after all, and then have some period of time where we have both at the same time or something like that.
Really? Okay.
Eric Ving, IETF. I just said to David, really? But I like the idea, of course, pretty much like Tommy. I think PVD is an encoder there, and your option is pretty much orthogonal, so there's not one or the other. And the last one, I'm really puzzled by this experimental status, because you are really looking for something which may stand forever, or you will get no implementation in host, for instance. I understand why you say experimental.
Yeah. No, and I think,
It's not RFC experimental though, right?
Yeah, they're looking for experimental status.
No,
Yeah.
there's, can you advance? You said, right.
In the draft, it's written experimental.
Please use the mic for your discussion.
Sorry. In the draft, as far as I know, is marked status experimental.
yes.
Oh, it's RFC.
Jelenko, two more comments. So I'm trying to think about a deployment scenario. So it means now I have to duplicate information in both experiment, like universal array and existing array options, because I cannot be sure all hosts support this, right?
No, I mean, well, so these examples are just, you could represent the current information like this. I would expect this to be used for new objects, which only exists in the universal array, right? So if people want, and part of the experiment is getting experience with what the hell is people going to put in there? Are they putting their PHP routing table there? Perhaps that wasn't a good idea, and we should shut down the experiment, right?
So in the second comment, like I'm in favor of experiment, but I just think 2 gears might be a bit short, because I wonder if it's just me or getting something supported on the routing platforms and getting it deployed after all this qualification might take slightly longer, providing I probably would not upgrade devices just to get this, right? So it needs to fit into the standard lifecycle management.
We have 2 implementations already. Tomek did one on the hackathon for Kia, and there's one on VPP, but of course that's not the platforms you run, presumably.
Eric Klein again. One of the things I forgot to say earlier was, I think there's some, doctrinal conflict about the kind of things that belong in RAs and that belong elsewhere. And I can try to send a pull request with some text about what sort of qualifies, but in general, my perspective had been that the things that you need to use the network belong in the RAs, and everything else belongs behind some service discovery mechanism, of which we have thousands.
Yes.
So, and to take the example from earlier in the week of the SIP proxy, the SIP proxy is not required to use the network, unless, of course, you have a network whose sole purpose is to serve a bunch of SIP-only devices, in which case that is their purpose. And that seems like a reasonable thing to put in here, maybe.
Yeah. Well, we have an infinite namespace here, right?
But not an infinite MTU. Yeah.
Sure, but you wouldn't. I mean, yeah, the network operator would only put options that made sense for the network. So
I'd like to close the mic line, so keep going, but.
Alex Petrescu. Generally, I support the way it is presented. Problem seems to be true. The way to address it seems to be appropriate. I would like to ask clarification. Is it intended to be only a router to host, or could it be also router to router?
well, the RA mechanism is by definition router to host, right? There is one open issue of, should it be allowed to go also in host to router to signal what you wanted back, as is sort of a DHCP-like option, request option, if you like, or, but I mean, router protocols, RAs are not, well, the CPE case is special, but then we say it behaves in host mode, right? So it depends on what you mean by router to router, I think.
Okay, I will take this question to the email list to explain what is router to router. Allow me a second question, which is with respect to judging success. Sometimes success comes from the availability of software tools to implement various things. Now we talk about a new format here. We see JSON, we hear CBOR, CDDL. I think I've seen also ASN1, I'm not sure, the syntax.
If you've seen that, please go and wash your eyes.
Okay, well, I do like ASN1. So the question was whether the discussion on the format to be used is still open or the decision is made, because CBOR, I'm afraid there is not really many implementations.
So I'd like to have us not discuss the format. We should be discussing today whether we want to do this. If we agree to do this, then we can discuss formats, but that's not the main issue for us to decide. So hold that for later.
Okay.
Thank you.
Tim Chang, yeah, I support this. I mean, the protection here is that we state that any unrecognized options must be silently ignored, so the host would just ignore it. My concern might be, and there's kind of an implication of the document, you might generate or need extra RAs to convey information, so you're going to increase the number of RAs that are seen on a network with the obvious consequences of that. A little nit in the document, there's a bit where it says the second purpose of the experiment is to, and then it ends there. So it's a bit of a cliffhanger in the document that you've left unfinished.
So this is the GitHub experiment. The URL is there. Pull requests welcome.
Okay. Right. Okay.
Yeah. Sorry.
What was I going to say? Yeah, the other thing that might be interesting to put in a little appendix for the time being, maybe not to put in the final publication, is a list of proposed RA options that have not made it through, to get an idea of the type of things that people have proposed.
So picked up the ones that are on our sort of schedule now. It's the network boot option that was proposed. Didn't get an agenda slot, but that's a URL for boot information. It's the one we're talking about. The PVDs, the Pref64 is there.
Yeah, I think that the point is, if this is something that removes the barrier to people getting things out there, then having a look at in the last few years as if we can do it easily. I sound like I'm volunteering here, just to see what sort of things people were putting forward. You sort of hand wave at the start. People put forward all these options. It just might be nice to have a list of what has been put forward as a draft.
But I mean, it's the ones we have discussed a lot, right? Are sort of, good examples of if we have had this, at least we would save all the working group time discussing them. But and we don't really know what else could be out there, right?
But to answer Bob's original question, yes, support definitely.
David Lamparter, speaking as someone who works in FRR, I'm happy to implement this if I can find the appropriate libraries, and I'm happy to ship it. So just as a statement.
Michael Abramson, I support this. I would just like us to look into the implications when it comes to the MTU. I'm worried about this, and some of this actually is multicast, which has implications on discussions on Wi-Fi and multicast. And if we think that this is going to grow, which means that we're going to send more unsolicited RAs, I would like us to think about that and conceivably come up with something that means that this is from the router to the host is sent as a unicast only and is never broadcasted or multicasted.
And I think that's also one reason I proposed this as an experiment. So we gave us some room for learning along the way, as opposed to sorting out all these issues.
Right, because if we think that this might, after a while, turn out to be several kilobytes of information, it might be better to just keep it out of the array and invent something more like, I don't know, yeah, but whatever we come up with.
Yeah.
So a new DNSSD would be mentioned here. So we probably need to figure out like what should go in there and what should go in here.
So I'm running this at home, so I have a picture of my family.
You can send that all the time.
Yes, I'm sending that on the link so everyone knows who lives here.
Right. So this is what happened with Usenet, right?
All right, let's
Yes, I
wrap
think that's
this up.
the end of
Thank you.
Well, go ahead.
No, I just wanted to, I'm not doing anything with RA right now, but this looks like a lot of fun.
And
Yes, so,
should Suresh get the last word?
oh, yes. Go
Go
ahead.
Hey Bob, hey Ole. So one thing I didn't see covered in the draft that I'd like to see is like how do you handle conflicts, right? So from, let's say you have some information that came in from DHCP that could also be given by this, right? Like, how do we resolve who goes first and things like that? That's something I would like to have some information. So I'm supportive of the experiment, but I would like to see a little bit more text about sending configuration information through different means and how do you resolve the conflicts?
Yeah. Pull requests, welcome.
Hey, I'm with the AD hat here. I ask you to do things.
Oh, sorry. Yeah. Okay, I'll take that as an order then.
All right, good. I mean, I have some concerns too. I'm worried that this is going to become very popular. There's going to be a lot of new stuff. There'll be very little barriers. So we need to be careful about what we require to be specified, but it's going to, yeah. So I don't know how we do that. And I'm not sure how to, thinking about it, there's a lot to learn here, but once we get this going with a type, I think we won't be able to stop it. So in any case, lots to discuss, but I think there was a lot, at least what I heard in the room was a lot of support for this. So good. Thank you.
Okay, it's a bit strange presenting something you think might be a bad idea and get lots of support, but oh well, let me put over for another 30-year-old idea to my co-chair. Gore is here as well. I think you're a two in a box. Well, sorry, it's no box.
Yeah, they got rid of the pink box. Now it's just an X on the floor. So this is the IPv6 minimum path MTU hop by hop option. I guess we should have considered putting it in an RA instead. Wait, that doesn't work. That's my other draft. You want
to do a double act here? So we all thought Path MTU discovery kind of worked because it's very widely implemented. And it does work, but it's not really useful. It's not working well. So we need something better. There's two bits to this. There's maybe an important piece at the transport layer, actually checking what works and verifying it. But here, there's a hop by hop option. And the hop by hop option is basically something new that we came up with, which was something old that we discovered afterwards. But it's maybe a good idea now because these two things come together. It can help. It doesn't help everywhere, but we assert that it helps in some places.
So the draft that was published this month, we changed this to experimental from standards track because at least Gary has convinced me there's a lot we need to learn before we try to do this permanently or something. The original draft just had it be for particular domains, but there's a lot. We need some real data here before we can decide what to do. Added a new motivation and problem solved section to better describe the purpose, and started describing experiments that we wanted to do and some editorial changes. The motivation, as Corey said, path MTU discovery, as in 802.01, doesn't work well in all places in the internet. I mean, it does work, but it's not reliable enough for what we want to do. Nodes in the middle may not send an ICM packet to big message. For various reasons, it may not get back to the source. Nodes are mostly relying on MSS for TCP, and we see a lot of defaults to 1280. And protocols that tunnel or encapsulate end up reducing MTU, and these mechanisms don't work there. And we're also sort of observing that as links are getting faster, 10 and 100 gigabit Ethernet, if we're limited to 1280 octets, the packets per second rate starts to go way up. And the difference between 1280 and 9000 at 10 gig is significant. And so if we want nodes to be able to do this, if we can get to bigger packets, it's actually a big win. And these are the 10 gig numbers, and add a multiple by 10 to get 100 gig, and we're not going to stop there. So if we could get IPv6 to work better with bigger MTUs, I think it would be a real win.
So turns out it's possible just to send a message through the network in the forward direction asking what MTU is supported, and then we can figure out what actually is deployed, and then we can start using this. But the point is that it's actually the sender who needs the message. So how do you get this information back to the source of the IPv6 packet? Well, we could send a path to packet to big message, an ICMP message from the remote right back to the source. And this isn't perhaps as stupid as it seems, because we do get other ICMP messages back from the remote all the way back to the source, because they're not generated on path. Maybe the state and middle boxes that let you forward these. So this could be a cool thing to do. And we're interested in people's opinion on that, and particularly measurements on where that works, because that could be helpful. We could also put the value that we find out for the forward path in the same hop by hop option we're using the return path, and return that value back to the sender. So the source knows this from extension header option. That's got different failure modes, but it's also possible. And we could also, of course, perhaps easiest of all, when the transport does it, we could simply put the value in a transport parameter and return it back over the top of the transport, possibly encrypted. If you had something like Quick, you just simply return this as a message size value back to the source. So now we have 3 ways of getting feedback, which complicates it and makes it more of an experiment. But I think there's good possibilities here that one or perhaps more might succeed.
Yeah, I mean, if we can make this a lot more robust, all 3 might not be a bad thing, but this is what we want to find out.
Right, okay, so we think it's a useful thing to keep this document going and standardize it as an experiment, because there are experiments to do. And in fact, there are many experiments to do, but some of them are listed here. The first one is the one I've just identified. How likely is it that the hop by hop option will be forwarded to the remote node? Remember that this is not necessarily a data packet, or it may be a duplicate packet of a transport protocol. So we don't require it to get there. We just want to know what its fate is. Does the packet with the hop by hop option get discarded? Does it traverse the link and get ignored? And does something else happen? Maybe it actually gets updated. How likely is it the ICMP message is returned to the source where it is originated from the endpoint, where it's originated from the node rather than from a box on the path? Because then you don't have routing issues, etc. So it works with load balancers. How easy is this to implement? Aha, we've already started that. We've been doing stuff at the hackathon, and we had quite a lot of fun there and quite a lot of success in making little things work. So this might be a really good place to drill. And how much support is there for jumbo frames anyway? One of the motivations here is to fix tunnels where you get less and less MTU, but one of them is to send bigger and bigger packets. Now we know Ethernet's MTU in homes and with smaller NICs is limited, but how much support is there really for jumbo frames out there? Can we actually start moving up to that? And I think there are more questions. I have a lot more, but I thought these were the ones we could actually drill into initially.
Jelinkova, I was just realized, so you don't necessarily have to get packet to big bag. You can get destination unreachable, and if enough of your header will be included, you can actually get that information even if your node doesn't support this, right? If your node doesn't recognize that option. Yeah, I think that's quite cool. Yeah, and I'm still going to give you some data on the probability of getting that to the node, yeah.
Yeah, please join, give data, great.
Eric Klein. I think if you're interested in jumbograms, technically they can be up to, the MTU can be a 32-bit number, right?
I think it was Ethernet jumbos we were talking about, not the V6 jumbos.
Yeah. Just a minute. I'm not that ambitious. Maybe 2K, 4K, 9K, 16. These are the sort of numbers I'm thinking of, not UDP packets that are enormous.
Okay, because the MTU option in the RA and in the jumbo, all that stuff is 4 bytes. So
cool if you think that believes.
Well, no. I mean, I'm fine with 2, and we can change the spec to say if the option length is 4 or is 6, then you know why. Also, I was going to suggest some text about is it the sockets API 3542. If you have receive path MTU option set, it would be good to get this bubbled up to the app. I think it's probably a very simple mention to suggest that as host behavior. Thanks.
Yeah, I agree with that.
Michael Abrams, I just wanted to comment on the MTU. Ethernet CRC calculations start to break down if you go way above 9K. I think it's around 10, 11, 12. That's where you start to risk you getting bit errors that are not detected by the CRC algorithm in use. So, and since Ethernet is eating the world, this is like a practical thing. We would need other link layers to do larger packets.
Fred Templin from Boeing. So I know this came up on the list and you guys responded to it, but in 1990, RFC 1063 tried to do exactly the same thing. And a lot of people put a lot of hard work into it at that time. Frankly, I think they were on the right track, which I think you are too. I think what happened back then is they were under a time pressure. They needed to get something out, and that's where 1191 came from. So I think we're back to maybe getting on the right track again. But it's good to look at that history lesson. I think it's important to see that a lot of people put a lot of time into it.
Yeah, the next version of the draft will probably cite that too.
Okay.
As prior work.
RFC 1063.
Yeah. And if people who were involved in that want to help us write the text around that, that would be great. I like history to know why we did things differently in the past. We may want to do them again. I think this case we probably do.
That only applies to people born before 1988.
I think I qualify.
David Lamputter. So I did a quick check of the Linux kernel, and as far as I can see, it does pass HBH options along, but it doesn't look at them while forwarding. And I believe that this is the result you will get from most, if not even all, routers. And I think that is something to keep in mind for this, because this is going to be hard to change.
Well, so You are correct. That's the status quo today. I would at least like to think that if we can show that this would be compelling and provides better overall service on the internet, that will encourage people to do it. I don't think we have to assume that implementations will never do anything they don't do today.
Right, but let me also make the argument that this is something where we need to consider making it as easy as possible for routers to actually implement it. And I'm not sure that an HBH option is the best way to do that. Maybe it's possible to find some way to transport this that is easier to pick out from the general traffic flow by the router itself.
So
I'm
I
not
had,
sure.
during the hackathon, I actually wanted to do that performance test difference between, what's the cost of processing an exception packet for path MQTT today versus stamping it with the hop-by-hop option. So I'll try to get that work done and publish that.
Shweta, one other question to tackle as part of this experiment would be the forwarding behavior changes when hop-by-hop option is present. If the path is taken with and without the hop-by-hop option would change. That would be important even for any other hop-by-hop options.
Yes, and we want to do stuff in this space to figure this out. However, we also, or at least I do as a transport person, assert this is only a hint. So we would have to have a transport layer mechanism to verify the bigger packet worked or not. So the hint would be completely wrong if they took a different path, and we want to know about that. But it wouldn't probably derail the transport.
Igor Lubashev, Akamai. What do you think about, I mean, you said that transport return path is obviously the most reliable one. And so you mentioned quick, and clearly quick, the patient is on the table, so we can do a lot of things to it now. There is another transport that is commonly used on the internet, TCP. And what do you think about opening up that thing in and maybe adding ability to set MSS after handshake? Could be very useful for your purposes, could probably be useful for others too.
So you want to renegotiate MSS when you discover something bigger?
Well, negotiation is kind of a weird thing with MSS. There is no negotiation involved. It's just you tell it.
Yeah, well, you tell it how much buffer space you have, which doesn't change. But yeah, I see what you're saying, and interesting. Let's think about this. We also need to think about how MSS clamping would interact if you didn't send it on a SYN. But yeah,
right. I mean, MSS clamping is only for really valid for symmetric path anyway. So this thing would be for asymmetric path, would work for asymmetric paths as well.
Let's talk.
Yeah. I think I'll close the line by Magnus there. Go ahead, Tom.
Tom Jones. So just on Eric and David's questions on implementation. So the socket API exposes the hop-by-hop data. It comes through. This is how we did the Linux implementation at the hackathon. And in the forwarding path, the hop-by-hop option processing is not great. Like, this is where the spiders live in the network stack. We've never done anything with this. But it's not going to be horrific to add support, so we could do this.
Michael Abrams. So in my 20 years, I've seen ICMP TTL expired packages go from being handled by the CPU to be done on the line card, I guess the NPUs and so on. Have you talked to the Silicon guys about doing the hop-by-hop option in Silicon and have the NPU, do so it never needs to get punted to anything intelligent?
Not yet.
Okay, because I think that was
it's a good question.
It was very valuable to making sure it's silicon friendly. And I know I've talked to them, and they can look like 128 bits into the 128 bytes into the packet, and I don't know what they then can do. But if you can do this, I mean, you're going to have to handle like 10K, 100K PPS of these as we progress up in line speed, and you're going to have 400, 800, 1 terabit per second line cards. It's going to be a lot of PPS on hop-by-hop options that the line card is going to have to process.
Right. Well, and then there's another question about, do you only put these in the SYN packets and then occasionally, or do you put them in all packets? So, yeah.
Right, but we definitely want to make this silicon friendly.
Magnus Westlund. Sorry. I definitely agree with this Mikael's commentary about making this line friendly. I'm very worried about in general that we're losing the possibility to have the network communicate to the end hosts and using the IP layers of the network layer to do this communication. Otherwise, you're going to have to do this processing in hacks in transport stacks level, and that's really worrying for me.
So I had closed the mic line, Eric, but if you're very quick, please.
Okay, yeah, I'll just repeat something that I told David Lampeter. I think it could very well be that devices that already do TCP MSS clamping can easily handle this, and devices that don't won't, and that's probably plenty okay. And there's another way to use this in conjunction with an ongoing protocol session, and that would be to just basically, in parallel, send this option from the source to the dest with no next protocol, which is like 49 or something.
59.
59. Thank you. To the next to the host. So you could keep your application traffic the same and just try to probe this in parallel. It'd be perfectly easy to do. Thank you.
So just to do this quickly. So as Tom mentioned, we played with this at the hackathon last weekend. It was a Linux host implementation, a BSD host implementation, VPP router implementation, a P4 router implementation, and I did a Wireshark dissector. I got to learn a bunch of stuff. Overall, it worked pretty well, but we decided to change it, of course. I mean, it is an experiment. So we did a version that this is not in the draft. So this has a return value and a return flag, or return bit, I guess I called it here. So if the source wants the destination to send back the MTU it received in a hop by hop option, it sets the flag, and then the destination would put it in the return value. And in order to keep this to still be 8 bytes, to not have it grow into 16, if you notice, you can only send even size MTUs back. So you divide, so it's shortened, essentially divided by 2. But I think if we lose one byte of MTU, it's not really a big deal, and keeping these short seemed like a good thing. So that's what we experimented with, and this is what it looks like in Wireshark. And I've almost got this completed, except for, notice it doesn't show what the next protocol is. So Wireshark is a little challenging when you're not doing the end protocol. So I'll keep at this. So yes, continue to talk to us. There's going to be some experimenting with this going forward, and we hope to have some data by the next IETF.
So I think we're almost out of time. Going for a last.
So I was going to say, if you have questions or comments, this is a thing we intend to increase our work upon as we go towards the next IETF, and hopefully report more at the next IETF. So please talk to us, not just now, but as we continue to do this.
Yeah, absolutely. I think there's a lot of work, interest in this work. It doesn't necessarily have to be that this is the solution, but I mean, this collaboration that we now have with the transport area is, so, I encourage everyone to come with data, come with new suggestions for that matter. This is kind of MTU retake. Ron, don't sit there like you're not going to run up here and do your 20 minutes. If you can do it in 20 minutes, I'll buy you a beer.
I'll do it in 15 for a 6-pack.
Here's the clicker.
Okay, Ron Bonica, and there are 4 drafts. I'll pause for questions after the second one. The first one is about the VPN contact. No, it's not. The first one's about.
Okay, hang on. This one?
Yes, that
one.
Thank
Sorry.
you. VPN compressed header.
Yeah, we got a bit messed up with.
Keep in mind the segment routing header that we just approved, because this is in the same line of thought. If you take a look at network programming, you'll find that there are 2 classes of SIDs. A transport SID that steers a packet to a terminal segment of an IPv6 tunnel, It's processed by the non-terminal segments left greater than 0. And examples of these in the SRH are end and endx. There are relatively few of these, in fact, 2, end and endx, and their semantic is very simple. Very little information is carried in a transport SID. By contrast, we have service SIDs. They determine the behavior at a terminal segment. They're processed only when segments left equal 0 at the terminal segment. And examples of these are end dx4, end dx6. By the way, this is all familiar to folks who've read the network programming draft. And there are relatively many of these. They have a very rich semantic, and because of that, it takes very many bytes to carry them. In any event, in IPv6, we have 2 ways to deliver instructions to downstream nodes. We have routing extension headers that steer packets from an ingress to an egress. They're processed at non-terminal segments when segments left is greater than 0. And they're well positioned to carry transport SIDs. And by contrast, we have destination options that determine behavior at the egress. They're processed only at the terminal segment. That's to say when segments left is equal to 0 or when there's no routing extension header at all. And they're well positioned to carry service SIDs. Now, there's one more observation we need to make. And that's the problem with routing headers. They're too long. Typically, they take 8 bytes of overhead. 4 bytes are mandatory, mandated by 8200. Most routing headers have 4 more bytes. Typically, they represent each SID in 16 bytes. So, a routing header with 3 SIDs is 56 bytes long. When it gets much longer than 3 SIDs, let's say 6 or 8, it's impractically long. These aren't ASIC friendly. Processing long extension headers is computationally expensive. That's one of the reasons you don't see very many routing headers on the internet today. Also, they impose unreasonable bandwidth overhead. Short packets, less than 500 bytes, are very common on the internet. Routing headers with 3 SIDs may become common. And a routing header with 3 SIDs would impose a 10% bandwidth overhead. So, where are we going with this? We're proposing 2 things. First, to encode transport SIDs in a new compressed routing header. And we talk about that in Draft Bonica compressed routing header. It's the topic of this talk. And we're also talking about encoding service SIDs in a new IPv6 destination option. Actually, a set of new IPv6 destination options, one of which is Draft Bonica 6-man VPN desktop. It's the topic of the next talk. Now, what does this new routing header look like? Well, the first 4 bytes are incredibly familiar. They're mandated by RFC 8200. The 5th byte should look familiar. It's exactly the same as the segment routing header. It's the next 2 bits that are new. They tell you how much we've compressed each SID. A SID can be represented by 8, 16, or 32 bits. And let's say we've talked about all this stuff already. COM tells you whether the SIDs are 8, 16, or 32 bits. Each SID maps to an IPv6 address through either a table algorithm or a lookup. And the IPv6 address is copied to the destination address of the IPv6 header, just like any other routing header. The interesting thing about this IPv6 address, it's a real IPv6 address. It identifies an interface. It's not a SID. It carries no semantics beyond what RFC 4291 gives it. So, for those of you who are in love with packet formats, this is what the compressed routing header looks like when the SID is encoded in 8 bits. You can see you can get 8 SIDs in a 16-byte header. If you need a little more to encode your transport SIDs, here it is encoded in 16 bits. And here it is encoded in 32 bits. We have some compliance extras here. An IPv6 address semantic remains unchanged once we translate a SID to an IPv6 address and copy it to the destination address. It has no semantic beyond what 4291 gives you. There's no need for transit routers ever to insert or delete extension headers. There's no need to have two instances of the CRH in the same packet. Extension headers are processed strictly in the order that they appear in the packet. No need to backtrack or anything like that. The status. We have multiple operators who've expressed interest in this. We have prototypes under development in Juniper, both on the forwarding plane and ISIS extensions to support SID advertisement. There'll also be in the next few days BGP advertisements to support the VPN destination option. And what we're asking for is wide review in Spring and 6-man, and after some review, a call for adoption in 6-man working group. Anyhow, I'll stop for questions here.
So we actually don't have time for discussion. So
Okay.
And we expect you to catch up on the next three.
Okay. Oh, I'm behind?
Yeah. Way behind.
Okay. Oh,
Oh, you can't be way behind. No, isn't it? Okay.
You can give me the
sorry,
hook
we're
after
not
the
going
next
to
one.
argue over that.
you can give me the hook after the next one. Okay, VPN destination option. Here is the anatomy of a VPN. You have PEs that learn routes from CEs. A PE associates, the egress PE associates information, VPN context information with a route it's learned from a CE, advertises it to an ingress PE. When the ingress PE gets a packet for that route, it prepends VPN context information to the payload. It puts that in a tunnel and sends it off to the egress. The egress pops it off. Now, what does the stack look like when it's sent across that tunnel? You have payload. You have VPN destination options with VPN context information, a compressed routing header, which is optional if you're taking any path other than the least cost path, and an IPv6 header. You see the new thing that we're introducing here is the VPN context informations. It's where we put VPN service sits. Do you have a need for security with this? No problem. Just put an authentication header or an ESP between them. What does this new option look like? Well, it's got an option type. ACK bits are when not recognized, discard 10, change bit is 0. You have variable length data, so you can encode as much information or as little as you need in your VPN context information, and you have data to go with it. Again, the status, we have operators expressing interest. We're building prototypes inside Juniper, looking for comment on the mailing list. Next steps, same thing, wide review, call for adoption. Next. Okay.
No, this, is it?
Yep, that's next.
Yep, sorry, thank you.
Okay, next. Nope, that's not next. OAM is next.
Not this one?
Yeah, no, not that one.
Not
My
that
OAM.
one.
Okay, I'll do it without slides, not a problem.
No, hang on. Yeah, well, go ahead, and this one, right?
Okay, that one, thank you. Okay, we have a new option. If you want to elicit OAM from a packet, you put this option in either a hop-by-hop, a destination header that precedes a routing header, or in the ultimate destination, depending on whether you want OAM information from every hop along a path, from segment endpoints only, or from the ultimate destination. The OAM option has some flags in it. The flags elicit a behavior from the processing node. The behavior is log a packet, count a packet, send an ICMP message to the packet source, obviously rate limited, or send telemetry to your NMS. Now, when you say log a packet, what information goes in that log message? As much as the processing node can put in it. It might have a very accurate timestamp if it can do it. It might have what port it came in on if it can do it, whatever it can do. The same for counters. What counter does it go into? Whichever one the processing node is configured to put these in. The policy can be as complex or as simple as you need. What does the packet look like? Well, like this. The interesting thing is the ACK bits are 00. Skip it if you don't understand it. The change bit is 0. What does that look like? What does the ICM We define a new ICMP message to send in response to that. What does it look like? It looks like this. It has a timestamp. It has the original datagram. Next steps, review, call for adoption.
That one.
Am I close to getting the beer?
You are very close to getting it too. I mean, we can.
Damn. Okay. This one is just for completeness. We don't expect it to be used very often at all. What happens? Remember the first message where we had the CRH that had these very narrow bandwidth SIDs along the way? Well, what happens if you want to use a CRH and you have a high bandwidth SID in the middle? Well, we have this thing called the segment endpoint option. It's to convey information to selected endpoints in a service chain. So let's say you have a service chain with 5 elements in it. You want to get information to element 3 and element 4. You put a destination option header in front of the routing header. It's processed by every segment endpoint. You put this new option in the destination option header. It has a segments left field. It gets decremented just like the segments left field in the routing header. It also has a list of containers in it. Each container has a segment identifier and an option. When segments left equals the segment identifier, then you execute the option. It's a way to have a high bandwidth segment identifier in the middle of a CRH. Now, do we expect this to be used often? No. In fact, you might choose, if you have a path that has a high bandwidth SID in the middle of it, to use an SRH. So for some paths, you might use an SRH because you need that. For others, you might use a CRH. But if you just have maybe one segment in the middle of it that has a high bandwidth, you might use a CRH with this. Again, call for adoption, wide review, and I think I have beer coming.
You absolutely have beer coming.
All right.
So we're thinking at the end of the set of lightning talks, we have 2 more lightning talks. We could take questions on all of them if we have any time left then. Would that
And
be
you'll
all right?
bring beer.
You will still get beer. Okay. No. So Frank, can you please come up? Let's see if I can.
So I wasn't
This is
aware
yours,
that
right?
this is a session about getting beer.
We'll do anything.
You just apply for lightning talks to get beer. Okay, that's the method to go and drain beer out of you. Cool. All right, so this is a quick ask to from IPPM to the 6-man working group to go and give us some guidance on how to proceed with IOEM in IPv6. So hopefully everybody's seen IOEM in a nutshell. So what we're doing is we're adding operational metadata into the packets, very much like what Ron was proposing, and we had a discussion with Ron to go and see whether what he's doing can be kind of synchronized with the work that happens in IPPM, because there is a shitload of overlap. And so we're adding metadata, and we need to find a place in v6 to carry the metadata. So the ask to 6-man from IPPM is really, we want to go and carry the metadata in extension headers, and we need option type co-points, both for hop by hop as well as destination options, depending on how we carry these things. And well, we need this thumbs up. Yeah, it goes the same way as what was done for PDM earlier on, that ended up in an IPPM shepherded RFC, so 8250, so that we can go and progress that work in IPPM. So what do we want to go and do? We have right now in IOEM, we have 4 types of data that we're encapsulating. 2 types are tracing data, which is pre-allocated tracing or incremental tracing that would go into an hop-by-hop option. We have proof of transit data, i.e. proving that you're progressing through a predefined set of nodes, and that we have a edge-to-edge option, which is just encapsulated at one point, not looked at throughout the network, and then decapsulated at the other node, which is what we need a destination option code point for. So the ask is really, well, we have a set of metadata defined. That is already defined in a draft, in a working group draft in IPPM, and we want to go and drop that into extension headers. That isn't without problems, right? So after we started the working group discussion prior to the IETF meeting in Bangkok, and that spurred a bunch of additional questions. And so we thought like, yeah, just asking for code points is one thing, but in addition to that, you want to go and have deployment considerations that go on top of that, so that we explain how the option would be used, because that's super useful for operators to consider, right? And because there is problems with that. We don't want to go and have the packet forwarding behavior really changed due to IOM being present. The IOM shouldn't, we're adding things, it shouldn't go and exceed the path MTU, we discussed that earlier. If somebody adds IOM information, well, you need to make sure that anything ICMP goes back to the guy who added that information as opposed to somebody else. And we should go and find information, well, we should go and come up with mechanisms that allow us to understand if there is misbehavior in the network without too much of a pain, right? So if that information would go, or the extension header would go somewhere where it shouldn't go, then, well, somebody should be able to go and detect. And then obviously we're going to adhere to what is said in 8200, i.e. you not inserting extension headers on the fly. And what the deployment option drafts, what the deployment draft then talks about is a couple of individual use cases on how you can skin that cat with one or the other trade-off. If you're sourcing and terminating packets right at the host, then you don't need double NCAP. You can insert the header there, or you can terminate the header at the destination. In transit networks, if you just want to go and do it on one particular individual domain, then, well, there's multiple sorts of what I would call double NCAP. You can do IPv6 and IPv6, and there is options whether you use a dedicated EULA address in the overlay so that, well, even if packets leak, they can never ever leak because I can't be forwarded. There is no addressing and no routing for them. We could also choose for a different option where we would use the same destination address, which makes it easier to make the path congruent. And then obviously you can use other parent protocols to go and carry that information. So you don't necessarily need V6 and V6, but if you're going to go and carry the information in Geneva, well, you can go and carry it somewhere else. I want to go and come back to the main ask, right? We really ask you to go and help us so that we can unlock the work and progress it in IPPM. And I don't know whether Tommy, who I believe is here, the chair of IPPM, can add additional color to that particular ask, maybe. You can go and give us a little bit of background of the discussion that we had on Monday on that very topic. And that's it from me. Thank you.
Sure. Thank you, Frank. Yeah, so I think the question and the feedback we'd like to get from both the chairs and the group, and any basic comments are welcome, is what's the most appropriate place to do this work. In the past, we have done work outside of 6-man. We want to see, is that appropriate to do here? How much do we want to do here? What type of relationship do we want to do on the work as far as the review? I think from our perspective, we are fine doing this particular part of the work in IPPM. The IOAM work in general has a lot of different encapsulation possibilities. This is one of the protocols that uses it. Some of those will make potentially more sense to belong in the working group that own the protocols that they're encapsulating with. Something like this, I think, is a bit more well understood, and I think we could feel confident doing it in IPPM if that is what the working group believes is the right thing to do. But if the working group believes that this should all be specified in 6-man and be done here, we'd like to know that as well. So we'd like to essentially just get an answer of what is the right place to pursue this work in. If it needs changes in review, that can happen in the future, but I think the main thing we want to know right now is where.
Thank you.
Hi, Shuping from Huawei. I think here we all agree that we should be carefully consider the IPv6 encapsulation of the IOM. But here the proposal is, we are proposing here is like to put the IOM data into the hop-by-hop or destination option. But if we look at the IPv6 extension header order, that is before the RH. So
And in the tracing mode, the IOM data along the path is going to become very large. So we are going to push the RH out of the parsing depth. And so that will damage the performance, the forwarding performance in the data plane. And we also have some the same thought on this topic, and we that was in the agenda, but we didn't get the slot. But fortunately, we are going to present in the next session in the RTG. So probably that we could contribute and provide some more thoughts on this topic. Yeah. Thank you.
So we have 10 minutes left of this session, so you can ask questions both for Frank and for Ron, I guess. Yes, please.
Michael Abrams, can you go back to the consideration slide that had like 6 points? When I read this, the first thing that came to mind is none of this is true with the proposed approach. Hop by hop headers, inserting stuff that's going to affect the ECMP, doing what I thought you were doing. I haven't read the draft, I just saw the presentation now. It just violates all of these 6.
So
I don't know if I misunderstand something.
Maybe
but
go read the draft.
Right.
How about that? So there's trade-offs to all of that, right? But we're trying to go and mitigate these concerns as much as we can. If there's other deployment options that can be considered, let's go and consider them. There's no free lunch, right?
Right.
If you add something, you change something. And we have to go and deal with that change in the most modest and operationally friendly way.
Okay. So are you going to continue doing this in V6 ops as well, or where is this going to be discussed, like the operational?
So I think that was the overall question on guidance on where we should go do the work. Right now, well, the core of the work is really an IPPM. This is where the data draft happens. This is where export considerations happen. This is where the Yang models are being done. There is a load of documents against how do you encapsulate that into multiple protocols, also presented in IPPM. That one, well, in particular, kind of is again jumping between these two deployment considerations, could go to V6 ops. I think it helps if we have a way that we can keep some consistency and the energy of the people that really care about that in a relatively concise forum. Right now, well, I feel a little bit like I'm on a dating tour, and I have to go and kiss every single bride and figure that one out. Not that I don't like that, right? But
enjoy it because you are.
But at some point, right, you want to go and take a decision and making everybody do the dating tour. Not sure, right?
No.
So we need to move this along. Suresh has raised his hand, so I'm going to let him. Yeah. Suresh?
Thanks, Bob. So the idea is like, Mikael, personally for me, like this should go in IPPM. The work should be done in IPPM. And the way 6-man is chartered is like 6-man gets like final say over whether this is going to work. So I think it's better that we talk about this in 6-man and see if there's like some showstoppers before starting the work, rather instead of like coming back during like the fag end of the IETF call, right? So that's really the idea, like, that like kind of talk to Frank to bring this up here, because it's if we figure out there's no way forward with this, it's like we rather do it early than later, right? And that's really the goal of this draft. Okay.
Right. Okay. So if you want the operational feedback on, well, Suresh, can we mute Suresh? I'm getting feedback. Or put headphones on, Suresh. Okay. I think the people who might be able to give feedback and say, if you do this to the packet, this will happen in the network, that those people would be, V6 ops would be a good place, or here. I don't think those people will go to IPPM and give you good answers there. I'm sorry.
Which is why we're here, right?
So Mia Kulevin, the responsible
transport AD for IPPM. Yes, we want this feedback. Please give it to us now. But like we also like, I mean, we take the feedback, we try to address it, and then we need to move on at some point, right? So either you make a decision here that this is like something that's really important for you and you want to work on in this working group, then you can have it. Or you provide us some feedback now and we can move on in IPPM. But we need this decision at some point. And of course, that also will mean that we will interloop with this working group in this community.
You know, from a chair's perspective, I think we would be happy to have this in IPPM. I think we would be also happy to review the format and, you know, help you if you need an early allocation request for a code point, for example, that we would be involved in that. But I don't know, Bob, I don't mind this being owned by IPPM for sure.
Can we maybe, as a starting point, can you find somebody who does like an in-depth review and provides like detailed feedback that we can work on in IPPN?
We have a waiver behind Ron. Thank you.
Thank you.
Cool, thanks.
Igor Loboshev, Akamai. This is a comment for all of the AOM drafts, I or no I. Please don't include anything that has the ability to send a packet elsewhere and then forward and ask the next hub to do the same. So any sort of loop back or anything else, because that's basically an awesome vector for reflected amplification attacks. So deployability wise, you put it in, it will not get activated.
That's a good point. And again, feedback from IPPM, there's two things that are mixed up right now. One is take things and record it. And the other thing is an instruction to do something. In most of these cases, the instruction to do something is take a copy of the packet or take a portion of the copy or something from the packet and send it somewhere. Well, maybe to a local log, maybe to a
local log is fine. It's like the old device can manage it, but
maybe to some node in the network. But I think that is there. That is where I think the intersection between the WIG and IPPM and Ron's draft is. And we already had a discussion that we want to go and find a way to go and consolidate that and also take these active things out into different draft and separate them out from just the recording portion. So I think that's been surfaced and it's going to be addressed. Thank you for that.
Good. Yeah, internet is a dangerous place, so keep it in mind.
Oh yeah. Dating is dangerous as well, by the way.
Gary, first, I was going back to the internet rather than dating. There we go. Some of the basic problems you've got, some of the basic questions you have are the same as Bob and I had. So it's a two-part problem. One is doing the OAM stuff and measurements, and the other one is kind of what works in the internet. And I'm not sure how we get the clue for both of them in the same place because they're two different communities. So happy to coordinate in some way or go to MapRG and present some data and all I'm saying is please don't lose the fact that other people might be doing something similar and we can all learn from the same experience.
Yeah, and I think next time we schedule things, it might be good if IPPM and 6MAN are not really scheduled for the same time so that we can go and be there, right? So point well taken. Thank you.
Well, super. Thank you very much. And we'll put that on the conflict list.
3 minutes back. You're running early. But that's all thanks to Ron. Thank you, Ron, for going fast, and I'll also go buy you a beer. Maybe right after the session. How about that one?
Actually, so the reason we're ahead of schedule is because of Darren at the beginning, because we had a lot more time. We expected that to go longer. So, well, good. I think we are done. So this concludes today's 6-man meeting. Please continue these discussions on the mailing list, and we will see you all in Montreal. Thank you. Oh, and we need the blue sheets back, please. Well, we're glad. Thank you, Aaron.
So currently this draft is owned by IPPM, right? And yeah.
Copy, send it to both.
Yeah. Just trying to restore the. There we are. What's the next thing coming up here? Should I be kind? Is this, this is not you, Pascal. Authentication, authorization for constraint.
You know, the IPPN, I don't see how you can